All right, so we are going to be recording this session. So for anyone that might want to watch this after we wrap up today, you will be able to view the recording by going to our data donut schedule. So I'll talk a minute about that in just a minute. But first off, I want to welcome everybody. Thank you for joining our Introduction to Python for Data Management workshop. I'm Michael Shensky, Head of Research Data Services for the UT Libraries. I'm glad to have you all here today. We do have plenty of donuts in the back for everybody that did show up in person. So please take as many as you like. We're going to have extras. Thank you also to everybody joining online. Glad to have you here. All right, so let's go ahead and jump into our content today. I want to quickly talk a little bit, just for a few seconds here, about who I am. I am our Head of Research Data Services for the UT Libraries. That Research Data Services team offers a variety of services to everyone on campus, students, faculty, and staff. You can see that those services are highlighted up here. We offer support for all phases of the research lifecycle, everything from the earliest planning stages through data collection, data analysis, publishing your data. At any point, please feel free to contact us if you need assistance with managing your research data. Everything from the DMP tool that you can use in the very beginning of your research to draft a data management plan to our different portals that we offer where you can download data that's been derived from the UT Libraries collections. We have a series of guides you can visit to get answers to common research questions related to data management. We also offer workshops like this. We have personalized consultations as well. If you're running into a particularly challenging research problem that's data related, feel free to reach out. And we also have the Texas Data Repository that you can use to publish your research data. So many services that we offer, workshops like this just being one of them. Speaking of workshops, I do also want to announce that we have 3 other workshops coming up this week. It is Love Data Week going on right now, which happens the week of Valentine's Day. Tomorrow we are going to have a slightly more advanced Python workshop, Python for data retrieval and visualization. So I hope you will join us for that. That one will be online only, so we won't have an in-person component for that one. But the remaining workshops this week on February 13th and 14th, they will both be hybrid. So they'll be on Zoom and here in the Scholars Lab, Data Lab in PCL. So please come join us for that. We also have one other workshop coming up at the end of February on Friday the 28th. That will be on how to share sensitive data related to human subjects. All right, so some quick logistics. Since we do have people here in person and we have folks joining online, please feel free to ask questions out loud as they come up. I also have another member of our Research Data Services team who's going to be helping me out as we get questions that are coming in the chat. He'll be able to let me know that those are popping up in there and I can answer those too. Our workshop's going to run until about 1 p.m. today. We'll have time for questions till about 1:15. So until 1 p.m. we'll be focusing on the content that I developed, a few slides and some hands-on exercises. And then, like I said, we'll also have time for questions at the end. So feel free to interrupt as we're going along. But also, if you have longer, more involved questions, you can save those for the end. As I mentioned, the recording today, as well as the slides and the code that we'll be writing, all those materials will be posted online at the same place. You can view our data and donuts schedule each semester. So the URL is up there. All right, so we've got a few goals for the session today. We're going to have a nice thorough introduction to Python, at least as thorough an introduction as we can fit into a single hour. So we're going to introduce the fundamental knowledge that you need to get started with Python data management. We're going to provide information about online resources you can use to continue learning more. So this is hopefully a good introduction to getting started with Python, but there's so much more that you will be able to learn as you move forward. And also again mention that we do have another Python workshop coming up tomorrow that you can join if you'd like to learn a little bit more. We're going to look at the specific benefits of using Python for data management, and we're going to focus specifically today on how you can use Python without having to install any software through our hands-on exercises that we're going to be doing in the Google Colab environment. All right, so what is Python? I assume that you all have a pretty good general idea since you're here in this session, but just really quickly, I will cover the basics. It is an open source interpreted programming language. It is cross-platform compatible, meaning you can use it on a Windows computer, you can use it on a Mac, you can use it on a Linux machine. The current version, sorry, that information's out of date, but right now we're using Python version 3, so you want to make sure that any code you're writing is Python version 3, not version 2. since there are some significant differences there, and Python 2 has been phased out. Python is used extensively in a variety of fields, so regardless of which discipline you might be in, and what you're studying, it's very likely that you will find a way to use Python successfully in your research, and you'll probably find many of your colleagues are already using it in different ways. There are many open source packages that you can install to augment the capabilities of Python. So pre-written Python code libraries that will extend the standard library functionality that can make it really helpful for very niche research applications if there are already existing packages that people have written to do certain types of work. And today we'll be focusing on how it can be used for things like file management, but there's so much more to cover as well: analyzing data, editing data, visualizing data, some of which we'll also be covering tomorrow when we go a little more in depth about data retrieval and data visualization. Okay, so I do want to talk just for a second here about why Python is important. Why is this something that might be good for you to invest some time into learning? It can help increase the efficiency of your research. If you can write code, you can automate processes. And that can save you a lot of time. If you're currently manually clicking buttons in a software application as a graphical user interface, you might be able to switch over to using Python code to automate that same exact work. That also facilitates reproducibility. If you have code that you can run to carry out your processes, you can share that code with others, and when they run it on their computer, they should get the same exact results. If you share it online through GitHub or put it into a repository somewhere, anyone else that uses your code should be able to verify your findings as long as you've also shared your data, and they can confirm that your results are valid. So that's really important for the scientific process. Facilitates collaboration, so kind of building on that. Again, it's so easy to publish code to platforms like GitHub that it can be really convenient to have code that you're developing in your research because you can collaborate on it with others. So maybe others in your research lab, others at other institutions who are working on similar things, however you want to work with others, doing that through code can be very convenient. It also allows for scheduled tasks. So if there's certain things that need to be run at very particular times, or on a really regular schedule, you can automate the running of a Python script to make sure that happens at a particular time. And writing code can be interesting, it can be fun. There's a creative element to it. Oftentimes, there are multiple ways to achieve the same end result. So you get to pick when you are writing code how to do that. And that can make what might otherwise be a tedious process a little more interesting. So as we can see here, if we look at current job postings that mention PhD in the description and which programming languages they also mentioned, Python is by far the most commonly referenced. So if you're looking for a career in academia, again, this I think emphasizes that Python is a good thing to be focusing on. Not that the other languages mentioned here are not also. Certainly, those are used for different types of applications and can be really important in different fields. But Python is a great generalist language that can often be beneficial to folks in any discipline. All right. So today we're going to look at how you can use Python for carrying out some really maybe tedious tasks or things that might take you time, or things that are really important but can be easily overlooked during the research process. So maybe you need to scan through a large number of files in a directory or a set of directories to find files that meet certain criteria. You can use Python to do that. You can use Python to automatically open files and edit content in a very clearly defined way using the logic in your code. You can work with data in very large spreadsheets. So Python is great if you're working with really complex, large data sets. Because those large data sets can take a really long time to sometimes open and work with in software that relies on a graphical user interface. Using code to work with large data sets can be more convenient. You can create, delete, move, rename files and directories. Pretty much anything you can do manually on your computer, there's probably a way to automate it using Python. You can retrieve data from external sources using an API. So we'll take a look at that today, but we'll go into more depth with that tomorrow. We'll schedule, we're not going to be focusing on this today, but you can do things like scheduling scripted tasks to automate data backups or publishing routines, which again can be really important and difficult to stay on top of if there are very particular times where things need to be carried out. All right, so it is ideal to run Python on the computer where your data is going to be situated, or on a computer that has direct access to the data. So, how many of you are managing research data on your local machine? Managing it on your computer? Okay, a couple hands go up, great. So in that situation, it would be ideal for you to be running Python probably on your own computer where the data is stored. In other situations, maybe the data is stored on a server somewhere or on a network file share where you might have access to it. In situations like that, again, you still might want to be running it on your computer where your computer already has a connection to the data or you have authorization to access it. And if your data is available online, it can also be useful to use Python on your own computer. You can quickly retrieve that and incorporate it into your analysis. One tricky thing, though, is when setting up Python on your local system, you can sometimes require some troubleshooting. So we're not actually going to go through that process here today. In just a minute or two, I'm just going to very quickly describe what that process looks like, because ultimately this might be what you want to work towards, is having Python set up on your system to manage your data locally. But today, because this is a very quick introduction to Python, we only have an hour to get into all of these things that we want to cover. We're going to be running Python in a somewhat simpler way. Still a great way to do certain types of research, but for data management, it's a little more limited. But it's, I think, the best way to provide an introduction to this topic. So what we're going to be doing is running Python in a cloud-hosted Jupyter Notebook environment. So we're going to be using Google Colab specifically. And in this scenario, it works great if your data is already available online, if you're pulling in data sets from external sources. So we're going to be grabbing some data from GitHub and the Texas Data Repository. So that works fine. It also works fine if you upload your data to Google Drive to manage it there. But it's a little more challenging if you're working with large data sets or a large number of data sets that are stored locally on your machine. Google Colab isn't maybe the best long-term solution for you, but that's how we're going to get an introduction to this topic today. All right, so very quickly, as I mentioned, what do you do if you want to install Python locally? If you are working on a Mac, see a number of laptops here, you might already have Python installed. So if you're on a Mac, you can open the terminal and type Python 3, and it should open up Python in your terminal window where you can start typing commands and running Python code. If you're on a Windows computer, you will likely need to install Python. It's probably not already pre-installed for you. So you'd have to go to python.org and the downloads page there specifically to download Python. Be careful because you can end up with multiple versions of Python on your system and they can all work fine. It can get a little confusing though. So if you've already got Python installed, you probably don't want to install another version. And then once you have Python installed, there are packages that you can install on top of that to extend the functionality of the standard Python library. So we'll be talking a little bit about that today once we get into the Colab environment. So once you have Python installed on your machine, you're probably also going to want to download an integrated development environment, a software application that you can open that facilitates the writing of your Python code. So we'll take a look at that here in a second. One that I would just recommend personally is Visual Studio Code. It's very popular, very widely utilized, very extensible. It's open source. It has a lot of great benefits, which I'm highlighting here as well. Again, a little bit of troubleshooting might be required to get this up and running, assuming that you have Python installed locally on your machine. If you download Visual Studio Code and open it up, you'll want to then create a new file that has a .py extension. That's how it will recognize that this is a Python file. That's what all Python files will end in, .py. And then you want to make sure that you have the Python extension installed. So if you go to your file menu, open the preferences submenu and get into the extensions pane, it will look somewhat like this. And you can click on Python and make sure that that extension is installed. That's going to provide extra functionality that helps you manage Python code. And then you should be able to execute your Python scripts inside of the code. So for some people, this all might go seamlessly. You can have all of this set up in 5 minutes. For others, there are some potential challenging issues you might encounter. For those that are going to download these slides after the workshop, I did include this slide here that provides some troubleshooting information for common issues you might run into. So I'm not going to go over that here because of our limited time today. But hopefully this will help you if you are interested in getting Python set up locally on your machine to troubleshoot some of these issues on your own. If you have any questions, you can also reach out to me for help. Okay, so again, today we're focusing on Google Colab because I think it's a great way to get really comfortable writing Python code and to learn the basics of the language itself. So just out of curiosity, for everyone that is here, how many of you written Python code before? Okay, great. So this is very much intended as an introductory session. So no prior experience is expected or required. And so again, this is why CoLab I think is the perfect way to run this particular workshop, because it allows us to focus on Python, the language, rather than all of the troubleshooting that might be required to get Python installed locally. So we can think of this Jupyter notebook environment that we're going to be working in as an integrated development environment that we can access online through our Google accounts. And it's going to allow us to write Python code in nice compartmentalized cells that we can run individually or run all together. So that also facilitates debugging, where we're trying to find issues with our code and fix them. We don't have to run all our code as one giant block. We can run it in pieces to see where something might be going wrong and address those little issues as they come up. And that's really common when you're writing Python code. Things probably won't go totally smoothly all the time. You might run into little challenging issues from time to time. And using the Jupyter Notebook environment can help you find and resolve those issues. So I do see that we have some things popping up in chat. Brian, anything that I need to address?
Mostly me just commenting.
Okay, cool. All right, so here we have a list of resources that are available. Again, we're limited on time today, so there's only so much we're going to be able to cover. I hope you'll join us tomorrow also for our next more expanded Python lesson. But these are great resources that can help you through the next stage of your journey learning Python, and just are great long-term resources to maybe bookmark and scan through to see if you think they might be helpful for you. I do also want to mention, since this is one of our co-branded Python workshops that's offered in coordination between the libraries and the open source program office, that our open source program office is a great resource on campus that is available to you if you are interested in taking Python code that you're writing for research and making it open source. So putting up on GitHub, signing an open source license to it so that others can freely use it and know what they can do with it. So the Open Source Program Office has been around on campus since the summer of 2023. It is a partnership between the Texas Advanced Computing Center, Enterprise Technologies, the iSchool, and the UT Libraries. We are really interested in helping people get started on this open source pathway. So for many of you, if you're just getting started with Python, you might be at this early stage of starting to use open source software. Python is an open source programming language. And help you get started with the next steps too. So maybe starting to contribute to other existing open source projects like Python packages that you might be using. Starting to share your own code. If you're writing your own research code and Python scripts for your research, you can share those openly on GitHub. And eventually maybe your project gets to the point where it's mature enough for you to accept contributions from others who have good ideas that you can incorporate into your code. And that could, over a longer period of time, turn it into a very active community of users all working together to advance a particular project. So the Open Source Program Office is a great resource. We offer training and events, things like this, workshops that are frequently held here and online as well. We can help you find funding that might support open source research software development. We also have a series of guides available on our website, opensource.utexas.edu. And we also offer consultation services. So if you have specific questions about anything related to open source research software, please feel free to reach out. This is our contact information. We'd be glad to talk with you and provide assistance.
Michael, could you check to make sure you're sharing your screen? Some people are saying they've seen you talking, and I said to make sure that they click the tab at the.
Yeah, we did have an issue with our last workshop where some people weren't seeing that tab. Okay. And so what seemed to fix the issue is logging off of the Zoom session and logging back in, and nobody else mentioned that they had trouble accessing it after that. So yeah, my apologies for anyone that might be online and not seeing my screen being shared. I can confirm here, I'm double checking, and it does show that it's being shared. And I assume that some people are able to see it just fine. Yes, question.
When is the additional class tomorrow? I didn't see anything about that online.
Yeah, it's at the same time.
Same time? Okay.
Yep, same time. It will be online though, so it won't be here in person. Tomorrow it's just going to be on Zoom. On Thursday and Friday, we will have workshops that won't be Python focused, but they will be here in person and online. So you can always join our workshops online, and most of the time they're also hybrid where they'll be here in person with donuts in the back again. Another plug for everyone that's just walked in recently. Plenty of donuts back there on the table. Grab a few. There's plenty to go around. Brian, any other questions? Okay, so that's it for slides. Now we can take a moment to jump in here to our Google Colab environment. This is where I think it gets really fun. We're going to be writing some code together. So we're going to be taking a look at these really basic foundational things that just about everyone needs to know in order to really start utilizing Python successfully. So we're going to get an introduction to packages and modules. We'll talk about variables and object types, operators, methods, and functions, the syntax of Python, so how to structure your Python code so that it can be interpreted successfully by the Python interpreter on your computer. How to write comments that help you remember what your code is doing. It can make it a lot easier for others to take a look at your code and understand what it does. We'll talk about conditional statements, the logic that you will incorporate into your code so that it will run only under certain conditions. We'll talk about loops, which are really powerful for automating processes at scale, like going through a large number of files. So these are the general Python topics that we're going to be discussing. And while we're learning all of these things, we're going to be trying to carry out some very specific tasks. So we're going to write Python code that will scan a directory looking for files. So it'll give us a list of all the files that it can find. We'll be using it to create new files. So this is really common in research workflows where you need to create new files as your analysis is being carried out, for instance, and saving those out onto your file system. We're going to try renaming files. We'll delete files that meet a certain condition, and we're going to read the content of files so that we can again potentially carry out some analysis. All right, so this is our link here. We type bit.ly intro-python-spring25. Brian, I don't know if you could share that in the chat. That'd be fantastic. So for everybody that's here in person, I'll give you just a minute to go ahead and type that in. Everybody that's here in person able to access the document? Fantastic. Okay, so I'm going to go ahead and navigate over there myself. And you want to make sure we're scanned up all the way to the very top of the document. So this is the Google Colab environment. It might have asked you to log into your Google account. If it hasn't, I would recommend logging in. You can use your Texas account or any other account for this, should work just fine as well. So what we're going to do before we really start anything else here, I want you to make a copy of this code in your own account. So when you do that, that will give you the ability to edit the code and make changes to it. That can be really helpful both in this workshop, if you want to test some things out as we're going along. It can also be super helpful down the road if maybe next week or next month you want to take what you've learned from this session and start to build out things that are related to your research using this as a foundation to do that. So in order to make a copy of this, we're going to go to File. And let me make my screen a little bit larger here. We're going to go to File. And we'll select Save a Copy and Drive. So once you do that, it's going to take everything that's in this notebook document and it's going to save it over into your Google Drive, where you'll have access to it perpetuity. So the first thing, before we even talk about Python, I do want to talk about the user interface here in Google Colab. So you'll notice at the top left of this page, there is a plus sign next to code and there's a plus sign next to text where my cursor is hovering around. That's because there are two types of blocks or cells that we can add into Google Colab Notebook. So we're going to see the first thing that we're going to take a look at here is text block, and then down below it, this is a code block. So text blocks just provide descriptive information. It's a way for you to add information that makes it easier for you to interpret your own code, makes it easier for others to interpret your code. Honestly, this is a great thing to use if you're ever going to give presentations about your research workflow, because you can run it step by step and show people results as you're going along. It works great for presentations too. And having that ability to create these text blocks is really helpful. So right here, I've already got a text block that is created. If you double click on that, you'll notice it turns it into an editable text block. And so I can change the words there. I can make them bold or italicized. I can add links. I can add images. You can do all kinds of things to really make this document, again, presentation worthy. This particular notebook that we're going through today is really designed for its functionality. It's very simple. There's not like pictures and other things that would make it look really nice and visually appealing. It's really all about getting into how the code works. But you can add these other things in if you would like when you're developing your own notebooks. Okay, so I'm just going to add an exclamation point to show you that this is editable. You can do other things too, like if I wanted to make this a heading, I could add a single hashtag sign, and now you'll notice it's a much larger block than it was before, and it's also collapsible if I put anything under it. So there is markup syntax that you'll need to get familiar with if you want to really fully customize everything. But fortunately for you, there's also these buttons here that can do the same thing. So this, if you want to make it a title, it'll add the correct syntax in there for you. Down below, this is a code block. So this one is fundamentally different in that you'll notice there's a little play button to the left here, and that means we can actually execute the code that is written in that block. Now this block has 2 lines of code. The top line is what we would call a comment. So because that Python line of code starts with the hashtag sign, in Python, that means that this code does not get interpreted. It's just purely like a line that gets ignored, but it can be useful for you as you're writing code to have these comments to remind yourself what this does. So this says this is an example code block, and you can change it to anything you want, and it will not execute that code. This is our first active line of Python code. We have a command here, print, and then here's where we need to get comfortable with the Python syntax. When you have a command like this, you need to wrap whatever you're going to plug in as a parameter in parentheses. So we have the command print, then in parentheses, we're putting in a certain value. And in this case, we're going to put in a string value, and it's the word hello. So when I run this, we're going to see that hello is the output here. So down below, this that's appeared is where the results of our cell running will appear. So if I clear that, it goes away. If I run it, you see it pops up. These are the results of that operation. And I can change hello to anything I want. So I can say something new, run it again. I get something new down here. Okay, so that's how the Google Colab environment works. We just ran a block of code together. And again, you can edit this on your own and you can change it to whatever you like. You don't have to type in the same exact things that I type. Now down here, you'll notice that we still have a print statement, and I'm not putting quotation marks around this input. I just have it wrapped in parentheses, and that's because it's a numeric value. So text objects need to be wrapped in quotation marks so that Python knows that they are a string of text rather than a variable name. And when we are dealing with numeric values, we don't have to put those in quotation marks. So those are print commands. Those are extremely widely utilized. That's a really helpful way for you to check and see what Python is doing. You can tell it to show you basically the contents of a particular object, and it will give you a string representation of that as a result. Okay, so I mentioned a little bit earlier that Python is really powerful on its own, but you can download additional packages or libraries that expand or extend the functionality of Python. That's done through packages. If you have packages installed on your system or packages that are available to you in the Colab environment, in order to make use of the functionality they provide, you have to import them. So think of it as like a toolbox in your house, right? Having a toolbox that has really helpful tools is great, but if that toolbox isn't in the room that you're working on your project in, you can't make use of those tools. So when we write import, think of it as you're bringing that toolbox into the room that you're working in, right? Now all those tools in that toolbox are available to you. So that's what the import statement is doing. And in this particular block, now we can see we have a lot more lines of code than we had before in our earlier example. We have 11 lines of code, and they are all importing these different packages that we are going to use in this particular demonstration today. So if you click the run button, you don't see any results. That's good. That means no error messages. Not every single code block will generate a visible result depending on what it does. But in this case, if you don't see an error message pop up down below, that means everything went fine. Now I'll show you what an error message looks like here in the Google Colab environment. So I'm going to try to import a package that does not exist in Colab. So there's a great package for working with geospatial raster data called Rasterio. I'm going to try and import that. And now we do see something that's popped up here. It says module not found error. It doesn't recognize that there's anything called Rasterio here. You can actually modify the Colab environment to install additional packages that you might want to use in your research. So it is possible to fix that issue. I'm not going to go into that today. We'll probably talk a little bit more about that tomorrow in our next Python workshop. But for the sake of time today, just know that when we write import, it's loading in these packages that are already available to us, that we've already installed, and it's making the functions that are defined in these libraries, essentially other pre-written Python code, available to us for us to use later on down here in other code blocks that we're going to write. If you ever want to see a list of all the packages that are already installed in your environment, you can, in Colab, type !pip and then list. Pip is the Python package installer, and it's what you can use to install additional packages. So we could use pip, for instance, to install that Rasterio package that it said is missing in Colab. Now you can notice a few ways that we are importing statements here, or importing packages rather. So most of them, it just says import and then the name of the package. Now some of these you'll probably commit to memory pretty early on as you're getting started with Python because they're so frequently used. So things like the OS package for doing things on your operating system, CSV package for working with CSVs, or the request package for grabbing data that's available online. The JSON package for working with data in JavaScript object notation format. Another really helpful one, especially if you're working with tabular data, is pandas. Has anybody here heard of the pandas package in Python? So definitely something to just remember, maybe commit that to memory, that this is something that you'll want to look into as you get more familiar with Python. In this case, I'm importing the pandas package and I'm giving it a nickname, PD. So that just makes it a little bit easier for me to reference it later on. It's shorter, it's faster. And you can also import specific modules of a package. So some packages are really large. They have a lot of functionality built into them. In some cases, you just want to import part of a package. That's what we're doing here on line 11. We're importing just the datetime module of the datetime package. That one's kind of confusing because the module and the package actually have the same name. Okay, so now we need to talk about using variables to hold values in memory. So these are the most common types of objects that you will encounter as you are working with Python. So I've defined them here so we can just very quickly get started before we begin working on some data management related exercises. So all of this is really essential for you to understand what we're going to be talking about here in a few minutes. One object type that you will encounter in Python is called a Boolean object. It can only have two possible values, true or false. So you'll notice that's highlighted in blue here. That's a hint to you that this is a Boolean object type, that it's something that Python is recognizing as not just a regular word. Here, if I type just a random string of characters, you'll notice that it's not showing up here in the blue color. If I type false without making it a capital F, it also doesn't show up in that blue color. So if we are defining a Boolean value, we want to use a capital letter at first, and we're either going to write false or true. Those are the only two acceptable values for Boolean objects. So next we have a string example. I talked a little bit about strings a minute ago, and a string is any line of text. So you'll notice the string is wrapped in quotation marks. It always needs to be wrapped in quotation marks. Those can be single quotation marks or they can be double quotation marks. But whatever you use at the beginning of the string, you have to have a matching quotation mark at the end. So either use a single quote at the beginning and the end, or a double quote at the beginning and the end. Down below here on line 7, it shows you how you can incorporate quotation marks into your strings. So if you use a backslash character here, that is called an escape character. That means whatever comes next is not treated as part of your code. It's treated as just a text character. If we got rid of that, we would get an error message when we try to run this code block. Next, we have an integer example. If you remember back to some of the math classes you might have taken, an integer is a whole number. So 1, 2, 3, a whole number, not a part of a number. It can also be a negative number, but it can't use a decimal point. If you do need to use a decimal point and represent parts of a number as well, you would need to use a float object type. So our float example that we're defining here is a float object type. And now as I'm going through each of these, you probably notice a pattern emerging, right? I have a name here that I've defined, and then I have an equal sign, and then I have some value on the right. These names are basically a way for you to easily remember where these things are stored in memory on your computer. So it's kind of like a pointer for you. So I can change these things to whatever I like. The names that I have here on the left are just things I'm defining. You can change it to some other name, whatever you want to give it. I just have named them here so that it's kind of easy to intuitively understand what they are representing in this scenario, but you can change them to anything you like. The equal sign is really important. When you have a single equal sign like this, it means that a value is being assigned to this particular variable name that you are creating here. And on the right of the equal sign is the value that you are assigning to this object type. So the next object type that we have here is an example of a tuple. So here, it's basically a special type of list that is wrapped in parentheses. And within the tuple, this is supposed to be an immutable list. It's a list of things that doesn't change, basically. If you have, and it's maybe not as common as what we'd call in Python a list, so a true list. And in that scenario, it is wrapped in square brackets. So here we have a list of different states in the US, Texas, Oklahoma, Louisiana, and you notice those are wrapped in single quotes. So they are string objects and they are separated with a comma. So this is a group of string objects in a list. This is a group of string objects in a tuple. Here we have another list. And in this case, I've used capital letters to represent the names. And also over here, I've capitalized list examples. So this is distinct from this one. So the capitalization in your variable names is important. If you are going to use capitalization, you'll want to keep that in mind, that this points to one location of memory on your computer. This points to another location in memory. Here I have another list example, and in this case, I'm plugging in integer values instead of strings. And that's totally fine. We don't have to wrap these in quotation marks. A list can contain any other type of object in here. So we could have a list of other lists. We can have a list of strings. We can have a list of floats. We can have a list of integers. The next object type I want to talk about is a dictionary object type. Has anybody here worked with JavaScript object notation data before? Okay, so that's a really common for we'll be working with it today. And kind of an equivalent way to manage data inside of Python is to use a dictionary. So in a dictionary, you're defining an object that has certain attributes. So in this case, we're creating an object that represents what we can consider the state of Texas. So some of the characteristics of this object are the name. Name is Texas. So here on the left side of the colon, we have the key or the attribute. And on the right side of the colon, we have the value for that attribute. So here's the attribute, name. The value for the attribute is Texas. Here we have another attribute called population. The value for that attribute is 29 million. Well, it was. Now it's gone up a little bit since some people have moved here recently. Here we have another attribute, the capital. What's the capital of our state? Austin. All right. So within a dictionary, you can have as many key value pairs as you like. Here we have major cities of Texas. So this is an attribute. What are the major cities? The value for that attribute is not a string. It's not an integer like we see in some of these other examples. It's actually a list. So the value for any key can be any object type. All right, so now if we run this code block, we'll see what it prints out here. So I'm asking it to show me in this dictionary example, look in the major cities attribute or in that key, and what is the value associated with it? I only want to get the first item in this list. So that's why it's returning Houston. So this shows you some of the complexity of Python syntax. There's a lot to get familiar with. We can use this print statement to show us anything that we have up here. So if I want to show that string example, you just have it say University of Texas at Austin. There we go, it retrieves. Let me scroll down a little bit here. If I want to see list example, what is contained in list example? I'm gonna go ahead and run it, and I see that list being printed out here. If I want to see the content of the dictionary example, I'm gonna run this, and I see a representation of the dictionary printed out. What if I type something here in the print statement that I say, I want to see dictionary example number 2? I get an error message because I've never defined that anywhere. So you can only work with objects that you have assigned a variable name to, right? If you've not defined it, then Python gets confused and says, there's no reference to this. I don't know what it is you're asking to work with, in this case, print out. And one final thing I'll show you that can be really helpful is, all right, so I'm going to go back to the list example here. You'll notice I'm using lowercase values. That brings up our states. If I write list example with a capital L and a capital E, we get this different list: Austin, Oklahoma, Baton Rouge, Santa Fe, right? Again, showing you the importance of managing capitalization in your variable names. And if I only want to see the first item in a list, I would put 0 in square brackets. So when you use those square brackets after the end of a list object type, then it's only going to give you the first item in the list. So Python is 0 index. That means 0 represents the first item in a list. If I put the number 1 here, it should pull up Oklahoma City. I'm going to go ahead and run that. There we go, Oklahoma City. Okay, so these object types are really important for you to memorize. String means text values. Integer means whole numbers. Floating point means a number value that can have a decimal value associated with it. And all of these different object types have certain methods that you can use to modify the objects or to do something to the objects. So here I'm going to go ahead and run this code block. There's a lot of different things happening here. But very quickly, I'll say if you have a string that you want to make uppercase, you would use the .upper method. And when you are using a method, you always use a dot after the object variable name. So string example, remember, was defined up here. String example, University of Texas at Austin. And then you use a dot to indicate that you're about to write a method. You'll write the name of the method, and then you'll write parentheses after that to indicate that it's a method of this object rather than a property of it. You don't have the parentheses here, Python's going to get confused and it won't be able to execute it properly. So when I run this, you'll notice that it's made University of Texas at Austin uppercase. We can also do things with strings like make them lowercase. That's the opposite of uppercase. So take the string example, make it lowercase, and replace all the occurrences of E in that string with an exclamation point instead. And we can see that's what it's done here. University of Texas at Austin, the E's have been replaced with exclamation points, and it's been made all lowercase. So that's an example of some of the things that you can do with string objects. You can also do certain things that are quite different with lists. So you can add new items to a list. You can get the length of a list, so how many objects are contained in the list. You can also convert from one object type to another. So if we have a number equals 1, right? So this is a whole integer, right? So this is an integer value. And if we want to convert that to a string, we can wrap the original value in parentheses and write str in front of it. That's going to convert it to a string. And so it's kind of hard to tell that's what that is down here, but this is 1 as a numeric value, as an integer rather than as a string. So sometimes it's helpful to convert from strings to integers, and other times you want to convert from integers to strings. All right, I won't spend much time going over the Python operators. They can be really important for numeric operations. They're pretty intuitive. If you want to add numeric values together, you'd use the plus sign. If you want to subtract numeric values from each other, you use the negative sign. If you want to multiply values, you would use the asterisk character. So don't use X. So that one is maybe a little bit confusing and maybe not, might not be what you assume, because usually when we're writing things out, we write an X for multiplication, but in Python, we use an asterisk to multiply. For division, we use a slash sign, so 4 divided by 2 would equal 2. This one, the percent sign doesn't actually give you a percentage, it's a modulus operator that will give you the remainder of a division operation. So 13 modulus 5 will give you a remainder of 3. And the plus sign can also be used to work with string objects. So in this case, the plus sign is not going to add the string objects together. What it's going to do is concatenate the string objects. So it's going to make a longer string that combines all of these things together. And so if we run this, it's going to carry out these operations. So you can check and see, 1 plus 1 is what A equals 2. All of those mathematical operations have been carried out. All right, so really quickly, I want to talk about conditional statements. So this is really helpful if you only want to carry out certain operations under certain conditions. So we can say if this number of data points, integer object, is greater than 30, in this case I've set it to 20, it will say let's run this analysis. If it's here, elif means else if this integer object is exactly equal to 30, then print this. Else, if it doesn't meet either of these conditions, then it's going to print this line instead. So if you run this code block, you'll see that we can control what happens in the results. So we need to find more data because we've set it to 20 and it doesn't meet either of these conditions. If we set it to 30 and run it, it will say just enough data. So we've changed what happens here in this code block by changing the value of this number. If we make it 35 and we run it, now it says, let's run the analysis. This is the end of the code block. So go ahead and try changing this number and see how it determines what print statement gets utilized. Okay, really quickly here, I mentioned that lists can be really powerful because we can iterate through those lists using a for loop. This shows you what that syntax looks like. Here we would use the for keyword. That's going to be how we kick off a for loop. Here we're going to specify what each individual part of the list is going to be referred to as. So here this is a new variable I'm creating called current num. And then I'm going to say in, and then I write the name of the list that I want to iterate over, that I want to process and go through each item in it individually. So then I'm going to say current number or current num plus equals. So I'm going to take the current value of it and then I'm going to add this integer value to it. I'm going to add 1,000 and then I want it to print out that new current num value. So when I iterate through this list of 1, 2, 3, 4, 5, 6, and I run it, so every time it runs, it's going to run for this one and this one and this one. And so think of a scenario where you might have 1,000 data files on your machine and you want to do a certain operation to each of them. You could use a for loop to say for each data file, open it up and make this modification to it. You can also iterate through key value pairs in a dictionary. Since we're short on time, I'm not going to show you how to do that. But now I want to get into working with our data. So hopefully you have a good kind of very quick introduction to the basics of Python. We're going to run this code block here, and it's going to retrieve some data for us. So now we're actually working with data, finally. What we're going to see here is that I'm defining a new variable name, Austin found pet response. I'm going to use the requests package that I imported at the very, very beginning of our work with this Colab notebook. I'm going to use the get method, so .get is going to allow me to use that method of the request package. And here, this accepts a parameter that is the URL for the location online that I want to retrieve information from. So you could put in a website address there that would retrieve the source code for any web page. In this case, I'm pointing it to a JavaScript object notation file that's available from the City of Austin data portal. And so when I run this, the next step is it's going to define that response as Austin found pet data. So it's going to take the response it gets from this City of Austin portal, and it's going to grab specifically the text. So you'll notice I use the dot here. and say dot text, but I don't have parentheses because it's not running a method of this result. It's getting the property of it. It's getting the text property. And then I'm going to use the JSON package to load in the text value of the response that I received using the request package. So I'm going to use the JSON package. I'm going to use the loads method because notice this is in parentheses. And I'm going to plug in the Austin found pet data, which is equivalent to the response text that I received. And I want it to tell me about the first pet in this data set. So that's what the 0 is doing. It's only giving me the first item in the list. And so when I run it, this is the information for the first pet in this Austin found pet data set. So you can go to most data portals for cities, government agencies, in pretty much any portal that you might go to. So if I go Austin found pet data, this is where this information is coming from. So you could go to any other data set here on the City of Austin data portal. So this is a visual representation of what the data looks like. It's showing us where people have lost cats and dogs in the City of Austin and where those pets have been found. And if I go to export, you can download the data as a CSV, right? I mean, this would require manual steps. So if you want to, this data is updated really frequently, new pets are being found all the time. You could do this manually every day if you're doing some analysis of which animals are being lost in the city or when they're most likely to get lost during the year. But writing Python code to automate retrieval of this information is going to be much more effective. So again, this highlights one of the benefits that I was mentioning earlier when we were going over the slides. What I'm also doing here with this, these 2 lines of code, with is used to temporarily open a file using Python. So I'm saying with this particular file being open, and I'm writing the name of a brand new file that I want to create. The reason why we know that this file is being created rather than one that already exists is because I have a comma after the name of the file, and then I have W in quotation marks. That means I'm opening this file in write mode, like I'm writing to the file. And then as means how am I going to refer to this file that I'm opening here? I'm going to give it the nickname file. So that's a variable name here. So I could say, again, this could be anything. This is not part of the official Python syntax. I could say with open this new file as open file. And what's happening on line 7 is I'm using the dump method of the JSON package to carry out this operation where I'm taking the pet data that's been retrieved from the City of Austin data portal. I am taking the open file object that I've created here. I'm going to put the information in here. And then this is an optional parameter where I'm saying indent 4 spaces for every key value pair that appears. So it's going to make this nice and organized. And right now, because we're in the collab environment, you'll see that when I run this, this data gets created right here, Austin found pet data. So if I double click on that, this is what the data looks like. So it's kind of messy, it's very condensed over here on the side, but this is an actual data file. If you ran this locally on your machine, you would have a JavaScript object notation file with this data set. And if you ran this Python code tomorrow, it would be an updated version of the data set. And maybe new pets have been found. So if you were actually going to be carrying out a long-term analysis of this data set, you might want to have your Python code run every night to grab the latest iteration of it and save it to your computer so you can see changes over time. All right, so we can also work with other file formats. So instead of working with JavaScript object notation data, maybe you want to work with a CSV file. So I mentioned at the very start of this presentation, one of the services that our research data services team provides to the campus community is serving as a point of contact for use of the Texas data repository. What we're going to do in this code block is we're going to retrieve a CSV that has been deposited by a researcher here at UT into the Texas data repository. We're going to pull it out of the Texas data repository, and we're going to see what that data looks like. Okay. So I'm going to have a variable name that I am using here. This data is about the dive characteristics of seals living in the southern hemisphere. And so they've been studied to see how deep they dive underwater, how long they stay underwater, and other types of dive behaviors. So you might recall I mentioned the pandas package earlier on. and how we were using the PD nickname or alias to refer to it. So that's what PD is there. It's the pandas package. And I'm going to use the read_CSV method of that package to retrieve a CSV file that is found at the following URL. So if you go to the Texas data repository and you find any CSV file in there, you'll be able to look up the path or the URL for that particular file, and you'll be able to use essentially, this same code here that we see in this Python code block in order to retrieve that CSV information. So when I run line 2 here, it's retrieving that data from its source online. Line 3 is going to take the data that's been retrieved and it's going to use the .to_CSV method to save that as a new file that is going to be called seal_dive_data.csv. So that's going to save a CSV file to my machine, or in this case, my Colab environment. And then I want to see a preview of this data. So I'm going to type seal_dive_df. This is the data frame that's being used to hold the data that's been retrieved from online. And I'm going to use the pandas head method to give me a preview of just the first few rows in the data set. So that's what's happening here. If I run this, it's retrieving the data from online. It's saving the CSV file, and then it's showing me that preview. And if I click on the folder here, this is showing me all the files that are available in my Colab environment, and you'll see that I have seal_dive data is right there. And if I double click on that, it's gonna take a minute to show here, but it pops up. This is the full data set that you can navigate through on the right-hand side. All right, so we've retrieved data in JSON format. We've retrieved data in CSV format. Now, I mentioned before that it can be really helpful to iterate over a list of things in order to kind of do work at scale. So that's what we're seeing here in this example. I won't talk about every single line in it because we're short on time. But what we're doing here is defining a new list. So in this case, it's an empty list that I'm creating. So I'm creating a new object called query list, and it's equal to an empty list. So if you just have an open square bracket and a closed square bracket, that means it's an empty list. And then I'm using the append method of this object to start to populate the list. So this list has a value of Austin, Seattle, Chicago, Topeka. These are cities in the United States, right? So it's a list of strings that represent major cities in the country. And then defining a function that I can call repeatedly later on in my code. And this is carrying out a set of steps. And I want it to carry out the same set of steps for every city that gets added to my list. So DEF, that is part of the Python syntax. That means I'm defining a function. A function is a routine, or it's basically a set of lines of code that are all going to get executed every time I call the particular name of the function. So this is the name here, API_query. And then up here, I'm defining what parameters this function will accept. So what things can I plug in to control how the function works? I have two parameters, one called query city and one results per page. And then I'm defining the function. So this is going to look pretty familiar. So here I'm creating a string. This is the URL that I want to get my data from. I'm using the request package again. I'm using the get method. I'm plugging in this new string, request URL, define where the data is located online. And I'm passing some headers that tell it how I want to retrieve the data. So in this case, I want to retrieve it in JSON format. And then I'm using the JSON package again to load the text value from this response into a Python dictionary object. And then I'm printing out the value of this response. So what this is actually being used for is to get information from GitHub about the number of users in each city that's represented here in my list. So when I run it, you'll see that it's telling me the total number of GitHub accounts for these cities. So in Austin, there are 36,000 GitHub users. In Seattle, 59,000. In Chicago, 43,000. Really interesting that we can modify this list here. And when we call the function, so we're going to iterate over every query in our query list. So every city name that's defined there, we're going to use the API query function in order to carry out this set of operations for that city. And so it's a very efficient way of retrieving data for a large number of cities. So again, I can add another one to the list here. Watch how fast I can do this. So if we want to get data about Miami, and I run this, There, now it's also retrieving this information from Miami. It just executed this complex function one more time in order to get these results. There are 11,000 GitHub accounts that are active in Miami. We can view a list of all the files in our directory. So if we want to use a for loop to see everything that we have created here in our Google Colab environment, we could use the OS walk method. So remember, OS is a package representing what we can do with our operating system. We're going to use the walk method to get everything that exists in our current working directory, which we can access by typing os.getcwd. CWD means current working directory. So we're going to use this method, and it's going to give us 3 resulting objects when it runs. It's going to give us an object that represents the root path to this directory, the list of all the directories in the directory, and a list of all the files that exist under this directory. So we could say for D in the list of directories, print the directory name. For F in a list of all the files, print the file name. So this is telling us what the directories are and what the files are that exist in our Colab environment. So we could use this locally on our machine to say, show me all of the files that exist in this particular location on my file system. And we can write another function here. Again, since we're short on time, I won't have opportunity to define everything that's happening here. But if you run this, it's designed to check for files that have a certain file extension. So we can see here, if I run this function that I've created called check for file type, I'm defining the folder that I want it to run on, in this case, the current working directory, and I want to check for all the CSV files. So when I run it, it's only going to list the CSV files. Maybe I change my mind and I want it to show me only the JavaScript object notation files. You see, I've just very quickly changed the list of the files that it's finding. We've already created a CSV file. So this is another method for creating a CSV file that I won't go over. But you can use os.rename to change the names of files. So you can pass in the original name and the old name, and it will update the old name to the new name. You can then check to see that that works. So when you skip ahead here, some of the other things that it's expecting haven't happened. So you do need to run your code blocks in order here to make sure that things are being passed over. You can also delete files using the os.remove method. So be very careful with this one. Whatever file path you plug in here, that will be removed from the file system. So those are some of the methods that I was hoping to highlight today. I know we've gone a few minutes over, but I did think it was important to kind of show you the power of what you can do with Python for retrieving information, saving it to your system in different formats, renaming files, deleting files. Again, we went through some of the stuff here at the end fairly quickly, but you have this code notebook that you can review, that you can test out, and hopefully everything we've covered at the beginning part here as we're reviewing each of those code blocks at the top of this notebook will help you understand what's happening in these later code blocks. So kind of think of these as challenge questions where now for you, it's a good opportunity for you to review what's there and see, do you understand what's happening in the code? What happens if you make changes to that code block? Can you update it to, like, we were changing here, instead of finding the CSV files, find all the JSON files. Can you make changes in the code that control the outputs? And do you understand what's happening? So I think it's a good way for you to practice moving forward. This will continue to be available to you. Hopefully you've made a copy of it. If you want to find it again after today, you can also visit our Data and Donuts schedule. So shortly after the workshop this afternoon, I will be updating this page to provide links to our presentation slides, provide links to the code in our Colab notebook, and also I'll add the recording for this session as well. All right. So with that, I will just quickly jump back to my slides and say that I hope this was interesting to you today. We do have a more advanced Python session coming up tomorrow that will allow us to go into more depth about some of the things that we've talked about. That session tomorrow is going to take place at the same time, 12 o'clock to 1:15. It will be virtual only. So we won't be here in person. So if you want donuts, make sure you grab some today while they're still here in the lab. But we will be back in the same lab for a workshop on R for data visualization. That will be taking place on Thursday this week. So we've got a lot going on for Love Data Week. This is just one of our early events that will be kind of kicking things off. Are there any questions about anything that I covered today? Yes.
Thank you very much for all the introduction. That was great. I was just wondering, so you just run this piece of code. So I know that we're using the collaborative sheet, but do you run this code in your terminal?
That's a great question. So if I go back to the Colab notebook for a second, you can actually download this. So I should have mentioned this earlier. So if you go to File and you click Download, if you download it as a .py file, that will download it as just a regular Python script. So let's go ahead and I'll save that. And then if I open it here, so I'm going to open it in that Microsoft VS Code application I was talking about. So you'll see what it looks like. And so all of the code that we were writing and testing out, it's all represented here. Let me zoom in a little bit so you can see. So that would be another good way for you to get some experience running code locally